This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back. This is Uptime, episode 18. Alan, what's the word this week?
The future of wind turbine technology is bright. More green shoots, more activity. It's looking better and better every week. I know it doesn't feel like it. It certainly doesn't feel like it, but the data indicates that positive things are happening. So keep some positive thoughts going and hope for some momentum, and we keep moving, especially Europe. Europe's seem to be really well in getting through this COVID-19 thing. United States, not so much, which gives the EU a huge advantage, quite honestly. People are going back to work. Kids are in school over in Europe. We're still, in the United States, we're still not talking about going back to school. Colleges are, I saw some more notes yesterday. Obviously, Harvard's not going back to school. I think Princeton's not going back. A lot of the Ivy League schools are not going back. There's no athletics in the fall. The EU is going to have a 6-month advantage on the United States. So that we're going to have to see how that plays out. What's new on your end?
DC's just chugging along. I think we're doing fine. It's interesting that we were one of the last ones to open back up and seemingly doing really well. The numbers have continued to come down. I think they're on a very tiny increase, like 30 cases to 50 cases kind of thing. But it's pretty quiet here. Things are feeling more normal, I suppose. But anyway, so in today's show, we got a couple different topics. We're going to talk about this really interesting 470-mile underwater cable between Denmark and UK. We're going to talk about hydrogen power a little bit and the future of that in renewable energy. A little bit more about carbon fiber versus fiberglass as far as construction of some of these turbine blades, which are just enormous, which is a common theme everywhere in the wind industry. Also, interesting white paper came out about the lifetime analysis of wind turbine components and kind of measured and discussed some of the simulations and then versus a little bit of reality that maybe they're not lasting quite as long as we hope and think they are. And so, what maybe some of the implications are there of, if these are going to wear out sooner than we think, then how do we need to adjust maybe like profit forecasts and other stuff like that. So let's double back. Let's start with, since we were just chatting about the EU, they're really interested in hydrogen power, both for airplanes and for just in general.
In large transportation.
Energy sector.
Yeah, large transportation.
Yeah. So what do you think about this? Obviously, one of the challenges with hydrogen power is that you have to get hydrogen. And currently, the easiest way, the cheapest way, is through natural gas reforming, gasification, right, which requires fossil fuels, which makes less sense because you're using fossil fuels to get away from fossil fuels.
That's true.
And then electrolysis, splitting water molecules into hydrogen, obviously the preferred method, but still pretty expensive and inefficient. So, So what's your take here?
Well, I think hydrogen seems to be a big push in the EU, not so much in the United States. And I think it has to do with just the abundance of fossil fuels in the United States versus mostly coal-driven things in the EU. And, just the opportunities before each of the different countries. Hydrogen makes sense in that it's creatable, and it can be created almost anywhere relatively easily. And what you need is extra energy to do it. And if you have a renewable energy sector that has extra energy capability or excess power generation, particularly at slower times where you're not using so much energy, can you use that to create hydrogen? You probably can. It may make sense to do it. And this is my sort of engineering 2 cents in all this stuff, is we should try it on a smaller scale before we define the whole entire EU doing it. Pick a country. let one of them, let one of those countries step forward. Just say France. Let's say it's France. France wants to try to create the infrastructure to see how it can be done, and see how it plays out, and then learn from that, and then expand it. I think one of the problems that the United Kingdom had with the EU was everything was universal, and this kind of seems universal. So I wonder how many participating countries are really going to be actively doing this, because some of them will be at a distinct disadvantage in it. But I think as a solution from an engineering standpoint, hydrogen does make sense. It's so easy to create. It is transportable in some means. It can be made locally, so you don't have to transport it very far in theory, like we do, like gasoline or coal or things like that. So it does have a possibility. And does it tie into our renewable energy sector? I think that's a big player there. Obviously, nuclear could help create hydrogen. Sure, it can. Can wind? Absolutely. Can solar? Sure. Yes, it can. That's where I think we're at right now. I think we're really early in the stages of this, but if they've defined a general marketplace, and Dan, what they seem to have done is defined it as larger transportation sector, trucks, ships, aircraft. Yeah. They're not talking about personal cars or smaller motorcycles or anything like that. They're talking about big
city buses.
Yeah, city buses, places where it's really hard, and things that use a lot of fuel, maybe cutting down some emissions on those larger vehicles, which is a really good thought. Just whether they have the technology to do it and the will to do it is, we're going to find out pretty quickly here.
Yeah. Well, and speaking of the EU, so there's this 475-mile underwater cable that's going to connect some of Denmark's renewable resources to the UK. So that's a long cable. Like, looking at the photo of this thing, it's impressive. The copper, it's like 3-stranded. Of course, each, I say strand, they're the size of like your arm. And then they're obviously made of like 150 smaller strands, which are still like the size of your finger. And this is it's an impressive cable. I mean, just like looking at the engineering, I'm like, good God, this thing's expensive. But it is expected to cost, I think it's at 1.8 billion to complete this. It'll be done by 2023. What are the electrical implications for making a 475-mile cable?
Well, we have transmission lines all the time, right? We suspend them from wooden towers and do that. I think the kicker is here, you got, it looks like a 3-phase power distribution system. So they got three conductors plus a neutral. That's kind of what it looks like. We don't tend to do that on power lines, aerial power lines, where we push everything so close together. But in this case, if you see the picture of it, it's pretty well packed in there. I'm always, they say a lot about underground cables, like telegraph cables initially, then it became telephone, and then it became fiber optic. The environment at the bottom of the sea is really, really rough. And so I'm not, if you snap off a telephone cable at the bottom of the sea in a horrendous storm, you're not jumping a bunch of energy into the ocean. I think just to dump a bunch of energy in the ocean, I'm not sure how they would deal with it. I'm sure they've looked at faults too and how to repair it. So it's a huge undertaking. It's a gigantic undertaking, even though it's just, we're just going to lay a cable and we're going to drop it off the back of a ship and it's going to fall, 1,000 feet to the bottom of the sea floor. Yeah, it sounds simple, but in implementation, it's really, really, really hard. It's an engineering marvel.
Yeah.
Yeah.
Well, just like you said, the idea of it potentially failing at some point and being like, hey guys, who wants to go fix the cable? It's like, not, nose goes.
Hey, Bob, it's your time. Here you go.
Yeah.
I'm not sure. Yeah.
But they've got to have a ton of, like you said, like fault systems and ways to diagnose exactly where
and redundancies,
potential trouble would happen. Yeah. So it's crazy that humans are just capable of stuff like that. That go species, go human race. That we can do things like that. Like you said, we've been doing that for a long time. Yeah. Like there's power cables connecting the whole world. Like it's not new, but it still just seems sometimes it's just like sometimes old technology is just brought back into the forefront, and you're like, wow, that's cool that we can do that as a species.
Just a lot of it I think is brute force. pure brute force because the environment is so rough.
All right, so we're going to talk a little bit about wind turbine blades. So carbon fiber is obviously becoming more prevalent as these things get longer. And Alan, is it mostly used in the spar where we're using carbon fiber?
Right.
I mean, are we going to see completely carbon fiber blades,
No.
or is it really just mostly structurally in the spar?
It's in the spar webs, in the loaded structural bearing portions of the blade. The exterior portion doesn't tend to be, well, it is. I've seen it in the tops. You think of the pressure and the suction side of the blades. There's carbon fiber in those too because those structures are loaded. But in wind, unlike in aerospace or even in automotive, in wind they like to mix fiberglass with carbon fiber and use carbon fiber sparingly because it's so expensive. So they'll interweave carbon fiber with fiberglass strands to cut the cost out, but yet increase the strength. On an aircraft or on a car, it tends to be just all carbon fiber. Why mess with trying to create your own special weave of whatever? And fiberglass is heavy and not as strong, which is a drawback in aerospace. But on wind turbines, they can kind of weigh that off. And a lot of the driver on the wind turbine side happens to be the cost of the turbines and the cost of the blade. So they can take out a couple $1,000s, probably tens of thousands of dollars, honestly, the cost of a blade by keeping some part of it fiberglass. Then it makes sense to go do it. I think as we go forward, are we going to see more carbon and more carbon? Yes, the Haliade X and the Siemens, whatever that DD wind turbine is, are going to have a lot of carbon fiber. And as they get bigger and bigger on these offshore units, it's going to get bigger and bigger. That means there's going to be more and more carbon fiber, which means the cost of blades is going to go up exponentially, because the rest of the world is not decreasing its use of carbon fiber. It's going up too. So the marketplace, the demand is going higher. The amount of production of carbon fiber has been relatively stable. So it just creates these real price discrepancies. And wind turbine industry is paying the price of that.
Yeah, well, I mean, they're saying in this article from Composites World that their goal is always at least 20% weight savings, moving from an all fiberglass blade to a carbon fiber reinforced one. And I mean, that sounds like, 20%, cool. But these blades normally, if they're all glass, are 110,000 pounds, like 50 tons, which is just absurd. I mean, you see them, and this is just going back to respecting the size of these wind turbines, which I remarked in a previous episode when I went to that farm in West Virginia to take photos and get some footage. Like you drive up on them, you're like, they are almost scary. They're so big. And then but you just don't think about their blades being that heavy, 50 tons, especially when they're made out of like fiberglass, like they're made out of steel. But anyway, so 20 to 30% is saving 15 tons, 30,000 pounds of weight. That's a lot of weight savings. And
right.
And that kind of ties into what we'll talk about in a second, which is, are wind turbines lasting as long as they're supposed to?
No.
Which the answer seems to be no. Which seems to be no. So if you can lighten these blades, does that help improve that scenario?
It can.
I mean, it has to, right? It has to have some effect.
Decrease stress.
Ultimately, increasing stress. So,
yeah. Well,
I mean, I'm sure bearings matter a lot.
They do.
All these things that are just, the contact points are critical, but
it's all interconnected.
Yeah, this sounds.
It's like a living, breathing being, on some level. A change in one part of the wind turbine has consequences elsewhere. Reducing the weight of the blades takes off load off the tower, off every other part of the wind turbine, which allows you to make those components, in theory, lighter or with a less expensive material. So it's a trade-off. The whole thing is a trade-off. That's when the hard decisions are made between engineers and management of what we're going to design this component out of, this wind turbine blade out of, and how does that fall out into everything else. And so that's where you see design decisions and differences between manufacturers because they've made slightly different design decisions, and that the marketplace decides who the winner is there. And for the longest time, cost is the biggest driver in wind, not length of life. Everybody's making, and this is where it sort of ties into the length of life, which is everybody's companies, for the most part, in terms of wind turbine manufacturers, are all saying the same story, which is we've designed the wind turbine to withstand 20 years of service. Wherever we're installing it, it's designed to withstand 20 years of service. And we're finding that that isn't the case. And so as an operator, what's happening over the last couple of years, some of the bigger operators, the more globally based operators, are coming back and saying, show us your calculations. Explain to us how you got to the formulation of 20 years, because we don't understand it, and we want to be able to validate. When you go off and buy the next set of wind turbines, we want to be able to validate your analysis that shows 20 years. And what it sounds like is happening in some of these boardrooms is the manufacturers are not willing to do that. They're not willing to show them the lifetime expectancy and how they're calculating it and what inputs they put into their modeling, which is strange. Quite honestly, it's strange. In other industrial areas, there are explanations provided of how they calculate the lifetime of those parts. And if you think about the electronic world, we have something called MTBF, mean time between failures. And that's a calculated number, but there's a lot of inputs in there to calculate it, and then we verify it, right? So if I bought a semiconductor or a diode or a resistor or some basic fundamental component, I have a really good estimate of how long that component is really going to live. On a wind turbine, we don't seem to be there yet, which is frustrating because it really hurts the industry when we don't meet those numbers. And I know it has brought down some of the OEMs in terms of wind turbines and not being able to meet that lifetime. And it should, right? If you're being sold a insufficiently durable product, eventually the marketplace will come back to bite you, and the word will spread. It's like, Dan, if you bought a new car from pick a manufacturer and it didn't turn out to work well, you're going to be the loudest vocal opponent to that vehicle versus the 20 people that were satisfied for it, right? So it turns out that having one vocal problem person or company that's bought some wind turbines that haven't lived as long as they were promised can really hurt the advertising and the marketing for that OEM going forward. So, we're seeing a lot of papers here, and Danny, you looked at some of these papers. What are you seeing in some of this stuff? Does it seem like they're even really close to the 20-year lifespan?
Well, the first thing is, it's funny how human nature doesn't. I mean, imagine someone's like, yeah, this is going to last 100 years or 10 years or 20 years. The whole 20-year number, to me, just screams BS. It's way too round of a number. How can you just engineer something to just be a happy 1 decade or a happy 2 decades? Or, you know what I mean? It's like the IRS, everyone, for self-employed people, I feel like you always know, like when you're doing your taxes, if you put round numbers in there, it like triggers an audit, because they're like, yeah, you didn't make exactly $75,000. You didn't make exactly, $2,000 in write-offs here. Like, it's always a weird, odd number, right? So
That's true.
Clearly they're just fudging that number. Like, why would it be 20? It's so even. It's such a beautifully even number. It's probably 16.25 years that they're going to. And so when you talk about engineering and calculating things, there's no shot it's going to come out to just such a nice number. And so then you say, okay, well, where are we actually, and like you said, if they're taking data, maybe it's 16, maybe it's 13, maybe it's 12.75. I don't know, but it seems like there's lots of components that are to blame for this, right? Like the bearings and
what do you
just overall design stuff. And
what do you think is the worst offense?
Yeah,
knowing and not telling anybody, or not knowing?
Oh, clearly the knowing. I mean, like, and this is a good example. Are you aware of the vlogger Casey Neistat?
No.
I mean, vlogging and YouTube is a little bit less of your generation, but he's the guy. He's got like 10 million subscribers, probably more than that now. He's a well-known, like, good human being. Followed himself around New York City. Well-known video blogger, right? So has his camera on his face.
Yeah.
Anyway, he became prominent. He made a couple viral videos early when YouTube was very young. And one of them was about Apple. And he was basically exposing Apple. He bought one of the new iPods. And after 6 months, the battery was pretty much dead. And he called Apple and they said, oh, it's inbuilt. You can't replace it, but you can buy a new iPod. And he was pissed. And he was like, this is ridiculous. And he made a video called Apple's Dirty Little Secret, which is that they claim the battery life is going to last X, but it only lasts 6 months. And then there's not a thing they'll do for you. It's not in warranty.
That's right.
You just have to buy a new one.
Right.
And it caused a big stir because it was a hot product. And it was this exact phenomenon. It's like, Apple knows this. I guarantee they know it.
Sure
they have some of the best engineers in the world, but they don't want you to know it. And they're not going to do anything to help you about it either. And that sounds like a similar kind of situation. And I don't know what you would do about it, except people just have to push back and be like, look, we're not, like, we need data. And they have it.
The market,
they have to.
The market's going to push back, and the larger players in the marketplace are going to be pushing back hard. Very hard, because on two levels. One, if they can understand what the likely failure modes are for the wind turbines they already own and operate, and can put an engineering team together to go figure out how to extend the life, they may just do that. But without having the data, the original data, like on a wind turbine blade, for example, if you don't know where the loads are, if you don't know where the strengths are, where the loads are, how the loads are carried in that particular blade, then how are you going to upgrade it, improve it, sustain it? And there's no way to do that. You have to have some of that fundamental engineering data to go forward. Otherwise, you're just starting from ground zero, and you might as well just start your own wind turbine company at that point, because you have to know so much about the wind turbine that it doesn't even make any sense, right? So the OEMs have to be willing to provide some of that information, and in the rest of the world, if today, no matter what component you buy, you expect to have some sort of part manual that comes with it that explains how it all goes together, right? Even the most simple things, it's going to be like that. And even on consumer items, it's like that today. So on an industrial product, it makes no sense. No sense.
Yeah, because you have to make money from it, obviously. Like, I know these Apple AirPods, for example, I've heard that the batteries, because they're so small, and they have a charge cycle, like, they're just not going to make it past 2 years. Like, I've heard that. Now, they don't advertise that, but, I'm not making money off my AirPods. Like, if I have to buy new ones in 2 years, so be it. But if this is expected to, like, break even and become financially viable, because I'm renting my iPods out over, and they tell me it's going to be 5 years and they only make it 2, like, why don't you just tell me up front? And then I could have adjusted my business model. That's, I think the key thing. Like, if people aren't transparent with each other, hey, this turbine's only going to last 13.5 years. So maybe you should adjust your business model.
Right.
Accordingly.
Right.
And I think that's a reasonable thing to do, because obviously you need someone to sell it to. And if you're upfront with them and they can find a way to be profitable, then they'll sell more turbines in the future. But every time they come up short, it's like, oh, great, we lost money on another project because they didn't make it to the end.
True.
We could have changed the numbers up front, or we could have trimmed costs somewhere else.
We see that
it's a missed opportunity for everybody.
It is. We even see that on our strike tape product, which is a lightning diverter used extensively on wind turbine blades all across the world. And we frequently run into operators or OEMs that say, well, we just don't need it, because it has a minor cost impact on the cost of the blade, for example. And you start running through the numbers, like, that's crazy. That's just that it's short time and long time foolish. Yes, it costs everything. Every part has a price attached to it, but how much potential savings are you going to gather by installing a lightning protection product that actually works? That money, one strike, will cover the cost of all the installation. Easily cost of one installation. But time and time again, operators will roll the dice and say, well, I'll just take the risk. Okay, that's totally fine. It's your money. But it just doesn't make any sense, because if the industry as a whole is trying to drive itself to get to 20 years, then making really short-sighted decisions like that is never going to make the industry sustainable. It just won't, because other forms of power generation will be sustainable for more than 20 years, and that's what you're competing against, and the marketplace will always make that decision.
Yeah, well, and I think that's just unfortunately human nature, where we would rather reduce pain today, even if a slightly more painful decision today certainly reduces pain in the future. Like, this is something I appreciate about my own parents. Like, do you know what a ground loop system is in your house?
Yes.
My parents, so they were due for like a new just not just air conditioner, but I think they needed like a new water. Their house, like they got a long good run out of their old. I guess it was their air conditioner, and then and so they went and they bit the bullet and got this ground loop system installed, which is way more expensive up front because they have to drill like a
lot of
200-foot hole into the ground,
right.
but they will certainly recoup the cost of it over time. It's also better for the environment. Like,
it is.
They care. So yeah, like we'd rather do this because we care about that part of it too. And but that's not the decision that most people make. They say, no, I'd rather just pay $7,000 today and not worry about the future rather than paying $16,000 today and being pretty certain that, even though you're going to recoup that cost. It's just not human nature to do that. And just same thing with with your strike tape lightning diverter. Hey, just put this on. They're like, maybe we won't have, like, they'd rather roll the dice on not having a problem because they don't have a problem today. If they don't have a problem today, it's hard to say that they're going to have a problem in the future. And that just goes for so many things. But yeah, and it's a shame that we're fighting human nature rather than just the black and white of numbers. Like, look, like that's why I bought a scooter, right? We talked about my electric scooter off air before. Mm-hmm. I bought an electric scooter to shoot around DC because when I take other little forms of transportation, it makes financial sense to buy my own finally.
Oh,
sure.
It's
like, it's kind of painful to buy one up front. Like, didn't really want to drop $500, but it definitely will save you money.
It'll save you money going forward.
Short term.
Yeah. And that's the same thing in wind. And I just, it's a little frustrating at times. Just, it's like, it is gambling. It's what it is. It's straight up gambling, right? You're trying to make predictions based upon what has happened in the past. That's not a really great way to make decisions unless you're counting cards, and you're not counting cards. You can, right? If you're playing blackjack, we'll just get to a simple game like blackjack. What if you've won 3 or 4 games previously? It doesn't mean you're going to win the next one at all. Those odds are not related. They're just not. It's just like rolls of the dice. Those odds are not related. Each roll is independent of the previous roll.
That's hard for human nature. Yeah.
Yeah.
Humans don't want to hear that.
Right.
They think they're always closer, but they're not. It's always the same.
No, we've gotten away for some really good rolls early on, and we don't foresee having a bad roll. Well, odds are going to catch up to you. This is how casinos make money. They know what the odds are overall, and overall they're going to win. And in this particular case, lightning always wins. If you're going to be out in service for 20 years, guess what? You're taking strikes. I don't care where you are. You're taking some strikes. The question is, how much damage are you willing to swallow? That's it. And they don't have any numbers. They haven't really thought about it all that much, and they haven't done any of the homework. And we have seen it time and time again where it's been literally millions of dollars. And for putting on something that's relatively inexpensive compared to millions of dollars, it's fractions of a percentage point, that would go away. But it's just human nature. That's all.
Yeah, well, and we've discussed that there's a couple places where maybe like a small town owns a wind turbine or like a school owns a wind, and it gets hit and it gets severely damaged, and they're just like, well,
that's it.
No more wind turbine. They can't afford to get it fixed.
Yeah.
And that's such a
downer.
It's like,
it's such a big downer. Hey kids, we're all about clean energy. Boom. Hey kids, the wind turbine's got to go away now. I'm not sure what it's teaching kids besides we haven't thought things through very well.
Well, yeah, just having that basic risk assessment and an insurance policy, not a literal insurance policy, but just
it sort of is, right?
The taking extra precautions to make sure, okay, X, Y, and Z are not going to completely derail us if we don't have it in the budget to spend. That's the biggest analysis of it. If you don't have $200K in your budget to fix something catastrophic, then what can you do to severely mitigate that risk of having to shell out that amount of money? That's the big thing. People talk about like leasing vehicles. Like leasing vehicles makes sense a lot of times because you're not going to have to pay for, your transmission is not going to blow when you lease a vehicle, right? The dealership still owns that car. They're going to fix that transmission. That's right. So there's pros and cons, but okay, if my company leases vehicles and we don't buy them, then we've mitigated some risk. We're not have to shell out all these huge costs. And obviously they're not just a company, but a personal thing too. But
like the lease, Dan.
But yeah, with all that stuff.
If you're going to have a lease for 20 years, that would be a problem. No one would do that. Right? The duration has a lot to do with your exposure, risk exposure. Yeah. That's just it. It's just like keep playing blackjack for days and days and days. You're going to lose keep playing dice days and days and days. You're going to lose. You may get on a streak now and then inside of that, but at some point you're going to lose.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.